Seekers of truth. In the last video, we set up some basic information and review on laws of logarithms and the definition of E. In this video, we are going to prove two of the most magnificent results in calculus, at least in my opinion. There's really no objective measure of magnificence. Okay, so we're going to prove find the derivative of the natural log of x. And to do that, well, let's see. The derivative of the natural log of x is equal to the limit as h approaches 0 of the natural log of x plus h minus the natural log of x, all of it divided by h. Okay, so this is just the difference quotient that we're so familiar with when we talk about derivatives. Okay. Now, if you recall from the last video, one of the laws of logarithms that we had was the quotient rule, where the logarithm or the difference of two logarithms is really equal to the logarithm of a quotient. So here we have the difference of two logarithms, natural log of x plus h minus natural log of x, so that becomes the natural log of x plus h divided by x. All of this over h. And again, this is the quotient rule of logs. And I am going to just pull the 1 over h out here so that it's a little bit easier for us to see. So this is the natural log of x plus h over x times 1 over h. Okay? So all I did was, rather than dividing by h, we're going to multiply by 1 over h. But wait a minute, whenever we multiply a logarithm by something, then we can also rewrite this in a certain way. So if you remember the power rule of logs, we have a number times a logarithm is equal to the logarithm of the inner part here, and that being raised to that number. So here we are multiplying by 1 over h. So this becomes the limit as h approaches 0 of the natural log of x plus h over x, all of this raised to the 1 over h power. Okay. And again, I'll make a note, this is the power rule of log. That's the power rule of logs. Now as we continue this, I'm going to simplify this expression in here. X plus h over x is really just x over x plus h over x. Okay, so this is x plus h over x is really equal to x plus x over h plus x, and this is just equal to 1. So I can continue to write and just simplify this a little bit more. This is the limit as h approaches 0 of the natural log of 1, because that's just x over x, plus h over x, all of this raised to the 1 over h power. And that whole thing is inside of the natural log. And at this point, if you look at this expression here, or at least if you just look at the stuff inside here, okay, this hopefully will remind you a little bit of E. Okay, so let me see here, or at least the alternate form of E that we did in the last video. Now it's not exactly the same. Okay, on the one hand you have 1 plus h, here we have 1 plus h over x. This here is being raised to the 1 over h. This is also being raised to the 1 over h. So it's a kind of like E. It's E-ish, but it's not exactly E. Okay? But we're kind of getting there. That's kind of the direction that we're moving in. Is eventually we're going to show that this expression here in the derivative has E in it somehow. So to make this problem workable, we are going to rewrite using a substitution. write using a substitution. So we're going to define a new variable. Let's call it w, and we'll say that w is equal to h over x. Okay? And that implies that wx is equal to h, which then also implies that 1 over wx is equal to 1 over h. Okay? So what I'm doing here is defining a new variable. Define a new variable, w, and then these two other equations follow from that definition. If we say that this is what w is equal to, then these two other equations follow from that. But in addition to this, if you take a look here, as h approaches 0, so you can see looking at this equation, as h approaches 0, w also approaches 0. So what that means is wherever we see h approaching 0, we can replace it with w approaching 0. Okay? Now, this all seems a little bit mysterious, but rest assured that this is a solid mathematical technique. It is used in a lot of higher level proofs, especially calculus proofs. It seems a little bit weird and odd, and that's because it sort of is, because it's kind of a very crafty little technique. So now we're going to rewrite this equation up here, this expression rather, up here in terms of w. So in terms of w. So now what do we have? So I've written out this limit minus some important information, some blanks here. Rather than h approaching 0, we can rewrite this in terms as w approaches 0. And instead of h over x, we can just write this as w. And instead of 1 over h, we can just write this as 1 over w times 1 over x. Okay, because 1 over wx is just 1 over w times 1 over x. And one thing I want you to notice here is that we started out having to divide by h, or multiplying by 1 over h, and that's gone. We still can't quite make any substitution, do any direct substitution, so we can't just take 0 and put it in here because we have some problems with division by 0. But let's see what we have now. So if we take a look at just this part right here, just that part right here, okay, and this limit right here. So we take the limit as w approaches 0 of this expression, that's equal to e. That's the equivalent of e. Okay. That's the equivalent of e. So let's look back at the statement of e here. E is the limit as some variable approaches 0 of 1 plus that variable raised to the power of 1 over that variable. So let's see, we have exactly the same thing here. The limit as some variable approaches 0 as 1 of 1 plus that variable raised to 1 over that variable. Now, you might say that we have a problem because you have the natural log here and you will have another variable here, x. But if you notice, this limit only applies to w. X is sort of a constant. W is actually the variable here. So this entire limit is equal to something quite amazing, and this is what makes it so magnificent. So that's all equal to the natural log of e raised to 1 over x. Equals to the natural log of e raised to the 1 over x. But now, if we apply the power rule one more time, except in the other direction, we can pull this 1 over x out to the front. So this is 1 over x times natural log of e. Okay? Now, natural log of e, let me just remind you, natural log of e is equal to 1. So all of this is just equal to 1 over x. So what we have from here is that the derivative dx of the natural log of x is amazingly equal to 1 over x, okay, which is a totally surprising result in calculus. I don't think anybody who first studies calculus would look at these two functions and say, "Whoa, the derivative of the natural log is just 1 over x." Okay. All right, so we'll stop this video here. This is quite interesting, and I'll start another video where we actually look at the implications of this result.